We want to look at some of the options for pocket toolpaths here on this part. Before we start with the toolpath, let's analyze it a little bit so that we can decide which tools we would need for finishing, and then we can look it up for roughing tool as well. So if so, first thing, let's if I try to zoom in the corner and see what corner radius we have. Okay, so uh, go to home, analyze entity, and then see what radius we have here in the corner. Okay, so the dialog box tells us that we have a 1/4 inch radius. That means the maximum tool we can use is 1/2 inch to finish it, right? The diameter of the tool. Um, but generally, it's not a good practice. Generally, we should select or pick a tool which is smaller than their diameter or the radius in the corner. So in this case, the maximum diameter of tool we can use is 1/2 inch, but we will pick it up maybe one size smaller. So let's 3/8 or maybe 1/4 inch, right? So that it can follow the radius rather than when the tool is finishing, it won't. You don't want to jam it in the corner. That will give us chatter in the corner. So slightly smaller tool to finish that pocket. Okay. Also, if I put it back to the top, also later on we're gonna use BCIT as island, in the pocket. So I would the way you can check what is the gap between those letters so that the tool can go through. One way is we can measure the gap by dimensioning it. Other way is that I can actually let's see if I can you go to wireframe and try to create a circle. So I'm gonna just create a circle of, let's say, 1/4 inch, right? So now you can see there a circle in the clipboard, and I can see the 1/4 inch circle is hardly fitting it through here, right? And then if I go between C and I, uh, yeah, the gap is probably less than 1/4 inch or exactly 1/4 inch, right? So really, the 1/4 inch tool won't go through, uh, or it would leave a little bridge there, right? So yeah, that tells us that we need to use something smaller than 1/4 inch to finish around or finish the ladders. All right, so let's start with simple. In the beginning, I'm gonna just escape from here. You don't want to create any circle or anything. I'm gonna just close that dialog box actually, uh, and make it fit with the isometric view. Okay, so to start with the toolpath, we're gonna just establish the stock first. So we would go in stock. I'm gonna pick a rectangular stock, keep it on. We're gonna just display it, and I will select all solids. Right. It would give us the stock size. No, yeah, it's telling me as the 12 inch by 12 inch. The stock we need. So we can keep it like that, or if the actual stock is slightly bigger, we can just change the numbers here. The thickness, the part thickness is 1.5 inches. That's where the Z is coming from. So the stock we're gonna just pick is a little bit thicker so that we can finish it later on and then face it off from the back side. So let's keep it 1.5 inch. All right. So that should give us a good stock here. So let's start with our toolpath. So I'm gonna just go. We are in toolpath here, and if I just explore it, the everything, let's pick a pocket toolpath. Okay. So we have contour, drill, dynamic, face, and all those. So we're gonna go with pocket for now. All right, like I said, we're gonna just let's try to create a pocket toolpath without thinking that there is a BCIT in the middle of the pocket. So I'm gonna just pick that bottom chain. We can pick the bottom chain or this top chain, but you don't want to pick the chamfered chain, right? So probably this bottom chain will be easier. Let's just uncheck the face selection so that it's picking the chain. That so that way it will pick up the depth automatically. Okay, the chain is done. So as you know, it's 12-inch part, so it's quite a size. So if we try to rough it out with half-inch tool, it's gonna take forever, right? So we're gonna rough it out with a 1-inch tool, and then we would uh, basically do a finish and remachining pass, remachining with the half-inch end mill, or actually smaller than half-inch end mill, like maybe we will use 3/8. Okay, so 1-inch end mill. So let's grab it from the library. We are on the end mills already. I'm gonna grab 1-inch end mill. So make sure you guys adjust your feet and speed. And I would just here in the comment, I would say rough pocket to the cut parameters. Yeah, for pocketing toolpath, one thing you don't need to be worried about is the chaining direction. So remember when we picked the chain can go left or right. It doesn't matter because software knows we're gonna be machining within that chain. So it can be anything. The climb or conventional, we are selecting it here. So we're gonna keep it on climb. Okay, the tip compensation, we keep it on the tip. Here now, how much material you wanted to remove, wanted to leave. So I will leave like 20 thou on the walls. The bottom, I would just go to 0 for now, just to keep it simple. But yeah, if it's the depth is important or you want it really close tolerance, then you can always leave some stock in the bottom as well, and then take a one cut finishing cut with the finishing tool. All right, uh, let's do that anyway. So I will just leave it like 10 thou on the bottom as well. Okay, on the roughing strategy, this is basically how the tool will be removing the material when it's emptying or hogging the material from that pocket. Right, so those are different strategies. You can go zigzag, constant overlap, parallel, and all these different options. Uh, Generally, the constant overlap works good with with most of the applications, but I would encourage you guys to try all of them and see how the result differs. So I'll just select that. And now step over is basically how much the tool is going to step over or shift each time. Again, by default, it's on 50%. The max we should do is 70%, not more than that. Then there's always chance that it will leave a little scallop in between in on the corners. So let's start with 60 and then we'll see how it goes. Right, so that will be zero point 0.6. Uh, the tolerance 5% is a bit open. Let's keep it at 2. Uh, so even 20 thou or 2% is looks like very vague, but because it is a roughing operation, so it's fine. Yeah, I mean anything else, we can just leave it for now. Entry motion, like how the tool is gonna enter. Remember, when we are programming manually, we always had a hard time to plunge the tool, or so we had to kind of drill a hole at the plunge point and things like that. But now the cam, it gives you some options, right? So we can turn it off, or by default it is on helix, so it's gonna try to create a helix within these numbers. If we have a narrow long pocket, maybe there's not enough room to create a helix, then we can also use our ramp, because ramp, it will automatically find the area where the software can make or fit a ramp. So we would just check this auto angle option. That way it would just find wherever it can make that angle. Generally, the helix is more efficient, or more, you can say, is easier on the tool. If not, then we can also use ramp. So let's keep it on helix because our pocket is actually kind of open area pocket, so it's not a really narrow pocket. Okay. So now here the minimum radius for helix is gonna make half inch, the maximum is gonna make 1 inch, and the Z clearance is that from, as you see from the image, that is gonna start the helix zero point 0.1 above the stock. We can keep it zero point 0.1, or we can tighten it a little bit to make it 50 thou. XY clearance mean it's gonna, if it find a room anywhere, wherever the software can create a helix, it would always stay at least zero point 0.1 away from a wall, right? So again, if we have really tight area, we can tighten that margin, but in this case it should work. The plunge angle is the your helix angle as the tool goes down. Uh, Again, if we are for aluminum, 3 degree angles generally uh, is recommended for most of the tools. But if you wanted to keep it really easier on the tool, we can make it to 2 degrees. Okay. And the tolerance. All right, so there's a direction of your helix is going to be counterclockwise or clockwise. You can either way. It's just depend how is it going to be climb or conventional mill. So we can keep it on clockwise for now. Uh, the counterclockwise will give more like a climbing effect, but because the whole tool is engaged, so it's not going to make a huge whole lot of difference. Now here, if the cam cannot find enough space to make a helix, then how you want it to behave. So do you want to plunge or skip? Generally, we wanted to skip because if you are plunging, it might break your tool. But yeah, in certain time, if you cannot get away, then we might have to plunge. Then we will keep smaller depth cuts. Okay. Yeah, entry feed rate. You wanted to go the actual feed rate, or you wanted to go with the plunge feed rate. Again, we generally we would use plunge feed rate so that it's a little bit slower when it's spiraling it in, when it's going down, right? And then keep going down with the finishing parameters. Again, the finish pass are, you wanted to make one pass of 10 thou, or you wanted to make two passes. So again, it depends what kind of strategy If you have really thin walls, we can turn this on option on and add spring passes as well. Now let's look at how you want your finish passes to be applied. Do you want finish outer boundary? You want to start finish pass as the closest entry? You want to keep the tool down? Uh, Generally, we would select one of these. So either machine finish passes only at the final depth or machine finish passes after roughing all pockets. So I would keep it at the final depth because you don't want uh, to machine finish pass every depth cut, right? And then override for your finish pass. Do you want to use a different feed rate or not? So again, and the lead in lead out, that will only apply to your finish pass, remember. So I will just make that part really small, only like quarter in, quarter of an inch, and this, let's keep it sweep, let's keep it at 30 degree. I'm gonna copy that information there. The depth cut, that pocket is a little bit deep, so let's see, we're gonna use point 0.1 depth cut or 0.15. In the depth, I don't want to use any finish cut because we're gonna finish it later. Again, by the pocket or by depth, we discussed it before. So here is the subprogram option. If this is a subprogram, we can check this out. Otherwise, if it's a standard program, we keep it. Uh, then keep the tool down for your depth cuts. Let's keep it off for now. Breakthrough, we would turn it on if this is a through pocket, but this is not, right? It's a blind pocket, so I would keep it off. The linking parameters. Let's turn on the clearance, retract quarter inch, high feed plane, let's keep it at zero point 0.1, top of the stock is 0, and the depth, I'm gonna just use that button and click here because that's how deep. Oh, let's keep it on absolute. Remember, everything should be absolute. So now if I keep it on absolute and pick depth cut here, our depth here, so the pocket is 3/4 deep. All right. Yeah. Only thing next is coolant. If you want to turn it on or not, I would turn on and say okay. There is our pocketing toolpath. So as you see, if I wanted to backplot it, you would see it how the tool is entering and creating uh, the motion. So, okay, let's go step by step. So there it is. The tool is going. So you see, the tool finds that place where it finds enough space to create a spiral. So it goes down and then start to create the spiral. So remember, we did not um, took the BCID in consideration. We wanted to just make a plain pocket. Okay, so it does that, and then it would do the second depth cut and keep going. So it's taking that 0.15 depth cuts. All right, let's try to verify it and see if everything is nice and smooth. So we go to verify. All right, so in tool components, I would just unselect the folder so that we only see the tool. And now let's run it. Okay, so the pocket looks nice and clean. Now let's look at by changing some of the parameters what happens actually. Okay, so now if I go into parameters, and one thing which we wanted to play with a little bit. So in roughing, so remember this what I was saying. So let's say if I change it to 90%, would it make any difference? Because if we still can get a nice and clean pocket, uh, this would be much more efficient, right? We want to speed up as much as possible. Okay, let's look at how does it look with the 90% step over. All right. So you see, because the way the shape is, here even 90% is working out fine, so we don't get any issue. It will be more when you have irregular shaped pockets, then you would see we're gonna start getting an issue. So the best way will be just uh, check it and verify, and if we you see within the those step overs, if you see that it's leaving some scallops, that means we need to make changes. But in this case, 90% is working out fine. Okay, so next step, we're gonna pick our finishing tool. But with the finishing tool, I can't go just finish it off because there is more material in the corners, uh, right? And so that will be too much maybe for finishing tool to take care. So we need to first clean up those corners with the smaller tool so that it can take off that extra material. Then we would add a finish pass. So that's what we call is remachining. Okay. So for finishing or for remachining the corners, let's just copy paste that toolpath. So right click, copy, and right click again, paste here. And then now we're gonna just change the tool here and change the toolpath type to remachining or rest machining, and it will take care. Okay, so we gonna remember we analyzed it that the radius is quarter inch, so we can only use half-inch tool, but we said we're gonna try to use a little bit smaller so that the tool can follow the radius. So I would go ahead, find a 3/8 tool, 3/8 diameter tool, and mill it right there, and then we would do the remachining with that. So I would just change this to rust milling. Okay. Now we go to cut parameters. That's where you will find this here. Right now we are at the standard pocket. If I explore that, you would see there's it's called remachining. Okay. So once that is on, now it asks you basically how you want the software to calculate the remachining regions, right? So the previous operation is one way of calculating. So it will look at the previous operation and then calculate. Uh, that's a generally more accurate way. But if you get some complication into that, we can always use roughing tool method as well. So you would just say what tool you used for roughing, and in this case we used 1 inch, right? And you give it tool, and then it would basically look at where 1 inch tool could not clean up properly. The clearance is that how much extra you wanted to go. You can keep it zero, but a little bit extra is always helpful. So it's going to calculate what the previous tool left and then go 20% extra. Do you want to apply entry exit curves to your remachining passes, so kind of lead in lead out? Sure, display stock, I would just check it out. We don't need to. So stock to leave, we're gonna leave the same stock as roughing, or you can leave it slightly smaller. And then yeah, the roughing is not gonna be uh, matter in this case. The finishing you can keep it on, or I would just check it off because we're gonna add finish pass actually later. The depth cut, yes. So because this is a smaller tool, do you wanna go 0.15? Okay, let's keep it for now, but it depends on if we are cutting steel, maybe I wanted to reduce it. Linking parameter, everything would stay the same. Okay, and now let's go. Regenerate. Okay, it did create calculated. So let's put that previous toolpath to sleep so that we don't see it and we only see the remachining. So as you can see, the tool is only cleaning up in the corners where the previous tool could not go in. Right. So now the remachining is done. Now we're gonna use the same tool and then do the finishing pass. So for that, I would, uh, I would just copy paste that operation one more time. Uh, so I would just do this. Okay, so to create the finish pass, let's copy paste that tool path one more time. Copy and paste. So this time again, if I go into the parameters, I would just delete all the roughing passes and only leave the finish pass. First of all, remember we left off some in the bottom, right? Some material. See here, if you go to cut parameters, you can see we left off 10 thou in the bottom. Okay, so first we're gonna take care of that, and then we'll finish the walls. Okay, so I will just make that to 0. Okay, and the stock on the wall, let's leave it still at 20 thou. The roughing, we're gonna leave that as it is. We want to rough it out, but the finishing pass actually, yeah, we don't need that. Depth cuts, definitely we don't need it because we're gonna just only be machining that last 10 thou. All right, and the linking parameter, now yeah, we're gonna spiral is gonna start from point 1 above. You can basically say my top of stock is negative zero point 0.6, so that this it goes down to close to the bottom and then starts spiraling from there. Then we'll create a spiral to take that depth cut. Right, so we took out the depth cuts and we're gonna now rough it, but it will be only like a one pass roughing. Okay, let's restart, regenerate. Okay, so with the 3-8 tool, we just cleaned out the bottom and made it to the depth. I would just put that to sleep by pressing T on my keyboard. So now we can see you see where the spiral is. So the tool went down negative zero point 0.6 and then it created a spiral, went to 3/4 D. So now the pocket is finished to depth. Now the only thing left is to clean the walls. So one more time, the same toolpath here. I would just copy paste the same toolpath. And now this time we would, uh, you know, turn off the roughing and then only leave the finishing pass and also turn on the color compensation. Okay, so the copy, paste. Okay, let's put that to sleep and go into these parameters. Yeah. So this time for no, first let's go to roughing parameters. So let's keep it standard. Here the pocket will be standard. I'm gonna take this out, make it 0 so that there's nothing on the wall. Yeah, this roughing, we need to turn that off so that it's not creating any roughing pass. The finishing, we're gonna keep it on. The finishing now, we will keep one cut on, uh, and in this time we will turn on the lead in, lead out. It's already on, but also we need to turn on the compensation. That is in the finishing parameter. So here the color compensation right now is on computer, so we would change it to where so that it gives us the color compensation code to adjust the size. Right. So with this, it should only give us the finish pass on the wall, just like a contour basically. Let's regenerate. All right, so there it is. So now we have only one finish pass on the wall, and if we zoom it in, you can see there's a lead in and lead out applied uh, for the finish pass. Now, as far as the islands are concerned, if we just add those island geometries to the pocket toolpath will understand that those entities or those chains which are nested into the pocket, they are islands. So yeah, we just put them all in one place. So let's say if the same pocket, my roughing, uh, if we go to chains and I said add, and now I'm gonna just add the add C, I, and T. Okay, so those are added. Say okay. Now, if I just regenerate it, it would automatically, uh, the toolpath would understand that those are nested inside the chain, and it will calculate them as island. So let's see how does it look. So see in roughing. Now my roughing cutter or the tool is leaving PCIT alone. But as you can see, the roughing tool cannot get into the details, into the narrow areas. So it's going to be just leaving a big lump of material around it. But similarly, I would just add that to my rest machining as well. So we say just add B C I N T. Now you can see I did not add the windows of B because yeah, it won't allow you to do that. So you cannot add a pocket inside an island, right? So for those little windows of B, we would have to create a separate toolpath to machine those. Okay. Yeah, if you by accident, if you do that, it's gonna give you an error. All right. So one thing you realize is that basically, if I do run remachining on it with the 3/8 end mill, which we did previously, uh, 3/8 end mill won't be able to go into the ladders, right? So we would have to change it to something smaller, like 316, or yeah, basically 316 or smaller. All right, so I would just change that tool here, add a 316 tool. So select from library. Yeah, this is what we analyzed it earlier, if you remember, that the gap between the ladder is roughly quarter inch. So we're gonna pick a smaller tool than quarter inch. Okay, so we're gonna use 316 for rest machining. Now the depth of cuts 0.15 is gonna be huge for 316 tool. So we should be even actually smaller than 0.1, but let's keep it at 0.1 to keep the tool path shorter. Okay, so I'll do the same with all other tool paths. So we would change the tool to 316, and I would just add those chains uh, into there. So going to tool, change to 316, say OK. And now just let's add chains in there by going into the geometry tab. Add, similarly, I would add the chains and change the tool for the finishing operation as well. So, yeah, this one we needed to change the comment to that this is not a rest machining anymore. This is a finishing, right? Change the tool to 316. That's all. And I would add the chains in there for the islands. Add chain. Okay, chains are added. Okay. And okay again. All right, so let's select all of them and regenerate. Okay, so as you can see, after regenerating, 316 and mill is able to go into the tight spaces between ladders and taken care of all the material there. Okay, so let's have a look at how it looks in the verify. And so after roughing it out, I think we can see that it's just leaving a big lump of material in the middle. The letters are not very clear. So what we can do is we can save this operation and then save it as a STL file and use that as a stock, so that then we can see how the rest machining is happening, and if the finishing is doing all right. Okay, so to do that, we go to here the verify tab, and then here it says save as a stock or STL. So it's going to ask you to save it somewhere. We can save it wherever you like. I will just put it on the desktop, and we can save it as a STL file of Pocket with Island. Okay, so now we'll just close this, and we're going to go into stock. And here you're going to select the file option this time, and then we would find that file and pick it as a stock. So as you know, we saved it as on desktop. There it is, my STL file. We'll just say okay, open. Okay, so now if I save it, say okay, it would show us, see there, it's showing the STL file on the top, so top of the part. So one way of to keeping it the view a little bit cleaner is that we just hide the stock. So it is gonna be there, but I would just go into the stock again. So we can go into the stock again, and I would just turn off the display. See, okay. So now it is there, it's in the background, but we won't be seeing it on the screen. So now I will select the rest machining and the finishing operations, and then we'll run it on the top. Okay, so I have selected three operations: the rest machining, the bottom cleaning, the depth, and the finishing. And let's verify it now. So as you can see in the verify mode, now our stock is basically it's a STL file from our roughing operations. Now let's see if our rest machining and the finishing operation run fine on it. Okay, so there is a 316 anvil going around trying to clean up the material between the ladders. Okay, I'm going to just fast forward it so that we can see it quickly, because the computer is slow. It's showing with the different color where tool is being machining. So it's machining in the corners and between ladders. So everything looks going all right. Okay, so that's the bottom. That's the final result. But as you can see, if I zoom it in, the bottom cleaning, toolpath is leaving those uh, little spikes in there. So that's coming from the step over parameters. Okay, so now if I just go back in, tighten those a little bit, we should be able to get rid of it. Okay, let's do that. So I'm going to just close the verify for now. So as you know, this operation number 3, this, if I just bring it on the screen, you see that that's where what it's causing, especially in the area where my mouse is right now. You can see it. There's big gaps there. Okay. So yeah, basically I would just go in and uh, tighten the step over a little bit. I think we had it on 90%. So we'll change it to something like 60%. And then we can see how it shows. Okay, so now it looks better, but we might still have some issues here. But let's try it anyway. So I'm gonna just only verify that toolpath because we know that other toolpaths have been okay. All right, so that's the result after verify. Now it looks much cleaner, but by zooming it in, I can still see a little bit of spike here and on the other side as well. Okay, so yeah, we're gonna tighten that space, the step over a little bit more to see if we can get rid of it. Okay, so in the preview in the back plot view, you can see this is the area where the bigger gap is, and that's where it's leaving a little scallop there, right here where my cursor is. Yeah, you can see that bigger gap there. So by changing, if we can eliminate that, and then we know that it's gonna be fine. So I changed the step over to 50% now. Let's see. Yeah, so in the preview, we can see now it looks much promising. The gap is not, uh, hugely different from other gaps. So I think we should be fine, but let's verify it anyway. So we're running a verify one more time. So as you can see now, it's not showing any uh, spikes or scallops in the area. Okay, so now the pocket is finished. The letters are also finished. The only thing is that we're gonna just add a separate pocket, just simple pocket toolpath to do those two eyes of letter B. So we are doing the two eyes for the B. So I just changed them and we're gonna add them into the pocket toolpath. And we selected a 316 end mill to do the roughing and finishing together. Okay, so let's see. Yeah, see, because it's trying to create those helix in there, and it's failing it, and it's giving us an error. So now we're gonna try to see if we can do it with the ramp rather than doing it helix. So I will go into the parameters. So in the entry motion parameter, let's change it to ramp. And yeah, I would just switch that auto angle option so that the tool can see wherever it can create the ramp. Okay, and then also the XY clearance point 1 is too much because those are really small windows. So I would just make it to 0.01 or something so that we can create closer to the wall. Otherwise, we'll fail it. All right, so now I did it, and you can see those pockets, the little eyes are done as well. Right, we have a toolpath there, and it is ramping down, so it's not plunging. All right. So at the end, we wanted to also try the open pocket toolpath. So what I would do is I'm gonna again copy paste one of those the last toolpath we just created for the windows for eyes of B. So I'll just copy paste that. Okay. And now we're gonna basically do two things. First of all, let's do the geometry. All right. So I'll just retain all, and let's pick the geometry here for these cuts. So I'm gonna just pick. Um, Actually, yeah, we don't want to pick the closed geometry like that. Rather, we're gonna pick it. I'm gonna try to pick like a partial loop. Okay. So with the partial loop, we wanted to basically we don't want to select the outer line. So let's see if it works. So what you do, I'm gonna click here. So it would pick that full loop, and then we would click the end side. So we wanted to end it here, right? So I'll click that. Yeah, so it ended the open loop now. It selected the open loop. That's how we wanted to do, because this is kind of open-ended pocket. So that's the geometry you want to pick. Now, yeah, once we create a toolpath, then we can add all the other cuts into it. But let's try the toolpath on one. So say OK. Okay, so it's saying it should be closed chain, uh, but we're gonna actually go into the manager, and yeah, I'm just gonna say OK. It's giving us an error, but that's fine. I'm gonna just say OK, and we're gonna change the toolpath to open pocket. Okay, that's this one. I want to put it to sleep. So we would go into the toolpath. In the tool, we're gonna keep it the same, but in the cut parameters, so in here we're gonna change from standard to open. Okay. Now when you do that, yeah, make sure this use standard pocket for closed chain and use open pocket cutting method. So we change it to open pocket, right? And it's going to overlap 125%, so kind of 0.23, so it will go out into the open end, right? So yeah, everything else we can just keep it the same for now. The only thing is the depth. Those cuts are not that so deep. So again, I will pick the depth with the depth button, and we wanted to go uh, yeah, this deep, somewhere here. Okay, so that's only 0.25 deep. All right. Yeah, so that's how open-ended pocket can be done, and we can add it into the operations. So let's see how it looks. Right. So after regenerating, now let's look at from the top view to see it. You can see the tool is going out of the pocket to machine it uh, clean towards the outer edge. Right. So yeah, if you have this kind of shapes where one end is open, we can always do the use the open end pocket and do that kind of slots, cuts, or open pockets.